All right, we are now recording. Let me go over a couple of announcements before we get going. Some of these I've given you before and some of you haven't heard. Let me first give you today's major one. And it's not that major, but normally I have office hours between the end of this class and the beginning of my next class is 11:15 to 1:15. Not today, okay? I'm taking my next class on a field trip to the planetarium, planetarium over at Stanford University. So I have to, as soon as this class gets over with, head over to the Birmingham campus, pick up the van, bring it back here, and then we'll be ready to go. And then from 1:15 until, well, that's when that class starts, until probably 4:15 or so, we'll be off campus, okay? But I'm normally in class from then. It's the time between 11:15 and 1:15, I've got to go get the van and get back here to campus. So I may be back here close to 1:15. It won't take me more than an hour, hour and a half, so 11:15 to 12:15, 12:30. That's when I'll be gone, and then I'll be back here sometime between then and 1:15. Okay, so that's that. I take it most of you are not that close to graduation, or some of you fairly close? Close. This term or next term? This term. Have you applied? Excellent, excellent. Okay. If you're graduating next term, or you even think there might be a possibility, this is a good time to start the process. Okay? First part is do a degree audit. Okay? In other words, get your degree plan. Okay? Then go see your advisor. Find out how close you are. You know, what you need to take and what you, how close you are to graduating. Then, we are working on spring schedule right now. So within a few weeks, you'll be able to register for spring. If when you see that schedule, one of the classes you need to graduate is not being offered, then that's a good time to try to start working on that. Get with the department or the chair or the instructor and see if you can get that class scheduled. If you can't, then you see if you can do a course substitution. You need to get that stuff settled before spring term begins. So that's why it's a great idea to apply to graduate the term before you graduate. So any of the rest of you, whenever you do get close enough, be sure you apply the term before you graduate, not the term that you're going to graduate. You can still do it, but it'll be a lot better on you if you do it the term ahead. The Office of Student Services is looking for students interested in becoming note takers. There are some students who have dexterity problems that they can't take notes, and our Office of Disability Services provides funding for that. So you'll get paid to take notes, okay? And Space Center there's a Space Center on both campuses. I know the one on Birmingham campus is looking to pay you peer tutors in areas of math. You would be great for that. English, biology, computer science, Spanish. So if you're interested in any of those, they pay you to do it. And it's a great opportunity to help a classmate and help yourself too, because I'd never learned math as well as when I had to explain it to somebody. Then it became mine. Okay, I could do it, but it became mine then. And I went to mark the roll and I forgot to mark it, so let me do that. Yes, sir. Walter is here. Gavin, not here yet. Dawson's here. Andrea's here. Josh is here. Jake is here. Allison's here. Chris is here. And Jalen just waited until his name was called to show up. Okay. So we're only missing Gavin. If we can just get him here, we'd have perfect attendance. Okay. Way to go. All right. Let's go from the current slide. And for those who just came in, it's not a major thing, but if you were looking for me office hours wise, right up to the class, I've got to go to the Birmingham East Campus and pick up a van for my field trip this afternoon. So I'll be off campus for at least an hour, maybe an hour and 15 to 30 minutes. So I won't be in my office during what normally is our posted office hours. All right, any questions on anything we've done so far? All right, we're in section 4.6. Chapter 4 is trigonometry, and 4.6 is graphs of the other trigonometric functions. So in 4.5 we did sine and cosine and all the different ramifications for those. The others all have one thing in common. They're not continuous functions. Sine and cosine are the only two continuous trigonometric functions. The others are not. So we'll be looking at those. We'll first sketch the graph of tangent functions, then we'll sketch the graph of cotangent functions, and then we'll sketch graphs of secant and cosecant functions. And you might think that these are going to get more and more complicated. Really, secant and cosecant are really easy to graph because you don't have to be all that specific about them. You just got to get the general shape. And then we'll sketch the graphs of some damped trigonometric function. Be sure you put the p in there. Never mind. But that's what we'll go from there. All right, so let's start with the graph of the tangent function. Now, what do we know about the tangent function? Anything? It's defined to be the ratio between the sine and the cosine function. Absolutely right. So that introduces the problem. What problem does that introduce? If it's the sine divided by cosine, what does that problem create down here? Zero. Yes, you can never divide by 0. So all the values for which cosine is 0 now become undefined. So it's not a continuous function. There are places where the cosine would be 0, and every place that is, the tangent's undefined. Okay? Another thing we know about it is an odd function. Because sine is odd, cosine is even, so tangent turns out being odd. Which means the tangent of minus x is the opposite of tangent x. So whatever it's doing over here, it's doing the opposite over here. Okay? Consequently, the graph of y is equal to tangent x is symmetric about the origin. Okay? Now, this is one you just said, cosine can never be 0. Okay? So you have to exclude all the possible values for which cosine would be 0. So two such values are pi halves and minus pi halves. Okay? Tangent can't touch either one of them. In fact, it's any of your half pi's. 3 halves pi, 5 halves pi, 7 halves pi, negative 3 halves pi, negative 5 halves pi, negative. All those half pi's, tangent is not defined because cosine is 0 at the half pi's. Okay. And here they take you through a graph of some of the values close to pi halves and minus pi halves. Notice here, oops, wrong way. Here they said that's about plus or minus 1.5708. So they did 1.57, negative and positive. And look at the values you get when you plug those in. Negative 1,255.8. That's rounded off. And positive 1,000. So it's going to infinity in both directions. Okay? Not defined as negative pi halves, not defined as pi halves. In between that, it is defined. Okay? For instance, 0, because the sine is 0 at 0, tangent's got to be 0 at 0. Okay? Now, at pi fourths, sine is root 2 over 2, and cosine is root 2 over 2. So that ratio is 1. At negative pi fourths, sine is negative root 2 over 2, and cosine is root 2 over 2, so therefore that's a negative 1. Those are key points for us. Keep that in mind. Then once you get closer to pi halves, they blow up. Getting very, very small this way, extraordinarily large that way. Okay? So, we call these places vertical asymptotes. Y'all had that back in Math 112, pre-calculated algebra. vertical asymptotes at your every half pi. Draw them in. If you're doing a tangent function, that's one of the first things you do. Okay? Now, here's how it looks. Okay? Now, this is just the pure tangent function. Now, here's another difference between it and cosine. In fact, tangent and cotangent are the only two that have this. What's the period for sine function? 2 pi. Yeah, 2 pi over b. And just for the plain sine of x, that would be 2 pi. Cosine. Period. 2 pi. Okay? Tangent and cotangent, pi. And here's the reason why. If you remember, all students take calculus. So all are positive here. Only sine and cosecant are here. Tangent and cotangent are here, positive, and cosine and secant are positive here. Well, you see, tangent is positive, negative, positive, negative, positive, negative, positive, negative. It has a period of pi, okay, not 2 pi, because down here is the x and y's are negative and negative, but this is tangent, like I said, positive, negative, positive, negative. So it repeats itself every pi. That's the one big difference between it and another big difference between it and sine and cosine. So it's domain, all real numbers except those half pi's. Every multiple of half pi you can't use. Notice it's no longer a 2n pi like it was for sine and cosine, which is n pi. You're at half pi plus any multiple of that. 3 half pi, 5 half pi, and so on. Range, though, and there's another big difference. What's range for sine and cosine? Yeah, -1 to 1. Tangent and cotangent go to infinity. Okay? So there's another. So several differences between how we do this. The period is normally pi. It has vertical asymptotes to every half pi. Range is positive infinity to negative infinity. Vertical asymptote, like I said, that's where the domain is not defined. Hey, look at that! Perfect attendance today. All right. Excellent. Okay. Ding, ding, ding. Okay. And, as we already noted, it's symmetric about the origin because it's an odd function. So there's how tangent looks. Now, easiest way to graph a tangent function, just like before. Okay, now, those places where sine and cosine were the max and min, what do we call that? What was that related to? Amplitude. You think this one has an amplitude? No. But that A value, it still has meaning. Because, remember, at pi fourths, this is 1, and at minus pi fourths, it's minus 1. Every quarter pi is at, this is where your A comes in. It's at plus or minus A. It's not an amplitude anymore, but that's where your pi fourths is. So that's one thing. The book never doesn't express that, but that's a good thing to keep in mind. The B influences the period. So if you had a bx, then you're going to, but now it's pi divided by b, not 2 pi divided by b. So you have to remember that. Now, once you know the period, okay, and where it begins and ends, then half a period behind this and half a period in front of it. Half a period behind, half a period in front. Those are going to be your vertical asymptotes. First thing to do, plot the vertical asymptotes. And they better be 1 period apart. And they are, you see? 1 period apart. Okay? Then, your zeros are in between those, and your plus and minus a's are in between those. So there, the A is important. It's not an amplitude anymore, but it is important. Okay? And then if you have phase shifts, they go the same way. We usually don't do that much shifting with tangent functions, mostly with sines and cosines. Okay? Any questions on that? Okay? Moreover, because the period of the tangent function is pi rather than 2 pi, the vertical asymptotes also occur at your half pi's, exactly halfway in between, well, half a period on one side, half a period on the other side of u0. The domain of the tangent function is a set of all real numbers other than those half pi's where you have vertical asymptote. Range, all real numbers. It goes forever. Okay. And by the way, tangent and cotangent is the only one that all real numbers is the range. Secant and cosecant come close, but not quite. Sketching the graph of this, y is equal to a tangent bx plus c. You could have a plus d out there, but they usually don't. The a amplitude has no meaning for tangent and cotangent anymore, but the a is still important for those quarter pies. Plus or minus a is for those values. The b still influences the period, but remember the period is pi, not 2 pi. So it's pi divided by b. And then I don't like doing this. The phase shift will still be what they call c over b. Okay? I like to factor out the b, and then what you have left over is c over b, but I just call that the c, and that's going to be the phase shift. Those are your key points. So your key points are going to be the asymptotes and the intercepts, and then the plus or minus a's. I put those in there. The book doesn't, but it keeps it more like we had before. Now, here's how they like to do it. 2 consecutive vertical asymptotes can be found when the bx minus c is negative 2 pi halves or positive pi halves. And then midpoint between any 2 consecutive vertical asymptotes is going to be your x-intercept. That's how you graph it. Do the vertical asymptotes, midway in between are your intercepts, and then midway between those are your plus or minus a's. Every time. The period of the function, they don't ever mention the plus or minus a's, but they're true. The period of the function y is equal to a tangent bx plus minus c is the distance between the 2 consecutive vertical asymptotes. We said it all before, but the period is from intercept to intercept, asymptote to asymptote. Plus a to plus a. However you want to say it, it's that period. That's your period. The amplitude of a tangent function is not defined, but don't throw away the a. The a is where you're going to find the y values, plus or minus a, at your quarter pies. Okay? And after plotting the asymptotes and the x-intercept, plot a few additional points, plus or minus a at the quarter pies. They don't ever say it, but you should do it. And finally, sketch 1 or 2 additional cycles to the left and right. Okay. Pretty easy to do after that. So let's sketch the graph of y is equal to tangent x over 2. So what are your parameters you can pick out here? Let me get my pen set up. What parameters can you pick out here? Tell me, help me. Say again? Okay, what's your b? No, it's just 1/2. The coefficient of that, yeah. 1/2. How about your a? A is equal to 1. Okay, that seems silly to say. Okay, how about your c? It's even sillier. 0. Okay, all right. So there is no phase shift. Okay, so a doesn't relate to amplitude anymore, not with tangents and cotangents, but what it does relate to is your quarter pies. So keep that, the value at quarter pies. All right, what does b relate to? Second? Period. And how is it related to the period? Pi over b. And the b is 1/2, so pi over 1/2 is the same as pi divided by 1/2 is 2 pi. Perfect. Okay, so we're back at 2 pi again. It seems like we never left. Okay, then what? And here again, I do the same thing we did before. Once you got the period, guess what we'll do next? Divide by 4. So the period over 4 is equal to what? Pi halves. Perfect. Okay, now you've got everything you need. Okay, so we'll set up our graph here. Okay, and we're going to do by your quarter periods. So we'll do, each of these is going to represent half a pi. I love that concept, half a pi. Good deal. Only thing better be a full pi. Okay. Okay. So this will be pi halves. This will be pi, 2 pi, 3 pi, 4 pi. Whoa, get back here. Okay, back out of there. Okay. This will be minus pi halves, minus pi, minus 2 pi, minus 3 pi. I didn't do as many on that side, did I? Okay. Now, so right now we're set up. Now, what you want these up and lower lines to be? We could do 1s, 2s, 3s, whatever. What you want those to be? Each tick mark 1, 1, minus 1. It is important in one sense, and we'll get there. All right, so we've got our setup here. Where does tangent usually begin? At the origin. What is the value of tangent at 0? And cosine is 1. What is the tangent of 0? Tangent at 0. And x equals 0, what's tangent x? Tangent of 0. Go back to your 0, because it's sine over cosine. Sine is 0, cosine is 1. 0 over 1 is 0. So here we have a 0 right there, x-intercept. Okay, now, where do we find our first vertical asymptote? That's what we usually do first. Where do we find it? Say again? Okay, you could do that, but basically it's half a period on this side and half a period on that side. Okay, and what's your period? 2 pi. So your first vertical asymptote would be at pi. And then you have another one at minus pi. So they're 2 pi apart. So that would be at 3 pi. And at minus 3 pi. Right? Boy, that didn't draw well. Okay? And halfway in between the vertical asymptotes, you have your, just like you did here, your intercepts. Okay. Now, the book didn't mention the dividing by 4 here. We did, because at those quarter periods, that's going to be what value? What? 0 at these. What's going to be in between your asymptote, your 0? Your 0 and your asymptote. Where are we going to be then? Plus or minus a. That's where the a comes in. And this happens to be 1. So on the left, you're going to be at minus 1. On the right, you're going to be at plus 1. Left, you're going to be at minus 1. Right, you're going to be at plus 1. Left, minus 1. Right, plus 1. Left, minus 1. Right, plus 1. So you can do, and then it goes to the asymptote, toward the asymptote. So this is what's happening. And this is how they always look. Something like this, okay? Something going down like that. There's your tangent function. Okay? Again, the book ignores a. A is important. That's where at your quarter pies. Plus or minus a, that's where you are at the quarter period. I say quarter pi. Quarter periods. Your B determines the period, and that's pi over b, not 2 pi over b, pi over b. And that gave us 2 pi in this problem. Okay, so your vertical asymptote is going to be 2 pi apart. Okay? And then your once you got that period, divide it by 4, those are going to be your key points. Now, they just said plot a few more points. I say plot those points, the quarter periods, because they're going to be at plus or minus 8. Why the book doesn't mention that, I don't know. Why did I leave off one here? I didn't draw this one in. Okay. Thought it was a little naked there. Okay. So that's what your tangent function looks like. Any questions? Does it make sense? Yay or nay? Okay. All right. That was example 1. Okay. There is a checkpoint. Please do the checkpoints shortly after you get out of class. Okay, as soon as you get an opportunity to. So let's see what, oh, wait, they're going to do it too. So let's erase this, and we'll see how they did it. Okay? Now, they like, as you were going to do, take whatever's in your parentheses, follow the tangent. X over 2 is equal to either minus pi halves or plus pi halves. If you just do the b, it works for you, okay? You can avoid all this. This gives you x equal minus pi or x equal plus pi, and those are going to be your first 2 vertical asymptotes, minus pi and plus pi, okay? I did the b gives you your period, half a period on one side, half a period on the other. It's the same thing, okay? Minus pi and plus pi, okay? Now, they did the quarter period. They didn't tell you they were doing it, but they did the quarter period. It's at minus 8 and plus 8. They never tell you that, but they do it, and it's there. At the vertical asymptotes, the tangent is undefined. Exactly halfway in between your intercept, and in between the intercept and the vertical asymptote are your plus and minus 8. Every time. So it's real easy to graph. If you get that first part set up, you got it knocked. Okay? So here is the graph, the one we just did. Tangent x over 2. Any questions? All right. Whoa, they're skipping example 2. And example 2 is sketch the graph of, they did the easy one, here's this one. Y is equal to negative 3 tangent 2x. Negative 3 tangent 2x. Okay? So let's identify our parameters here. What are they? A is actually negative 3. Okay. Next. Is 2. Is that what you said? Okay. And what does that imply? The period is pi halves. And then what's the next thing we do? Divide it by 4, and the period over 4 would then be pi halves divided by 4. Anybody? Help me, help me. No, divided by 4, not multiplied. And not divided by 1/4, divided by 4. Okay. Pi halves divided by 4 is the same as pi halves times 1 over 4. And that would be pi eighths. Okay. So that's going to be our interval of interest. Okay? All right. So let's start the graph here. Now, our horizontal interval is the pi eighths. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Negative 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Okay? And then we'll go up 1, 2, 3, and down 1, 2, 3. We'll go 4 or 5. Yeah, whatever. Okay. Now, So this will be pi eighths, pi fourths, pi halves, pi. Okay, negative pi eighths, negative pi fourths, negative pi, negative 2 pi. No, this is pi halves, this is negative pi. Sorry. Negative pi. Okay. We'll go up 1, 2, 3, 4, 5, and down -1. Get out of there. -2, -3, -4. Okay. Okay. Now, we're all set up. Where do we go from here? Where does tangent usually begin? At 0, okay? So 0, 0 is there, okay? Now from there, go half a period to the right and half a period to the left, and that will give you your first 2 vertical asymptotes. So what's that? Your period was pi halves, so what's half a period from 0? Period is pi halves, what's half of that? Pi fourths, okay. This time I'm going to put the asymptotes in red. I sort of like to do that sometime, meaning you can't touch it. You can't go there, you can't have a value there. Okay, so that's going to be pi fourths. That's a pretty ugly one. Minus pi fourths on this side. And then we'll go 1 period away, which is pi halves. So that will be at 3/4 pi, which will be right here. And minus 3/4 pi, get out of there. That would be right here. And then you would have another one, another somewhere out here. And 1, 2, 3, 4, somewhere here. Okay, those are your vertical asymptotes. I don't know what that's doing up there, but let's get rid of it. Okay. Now, let's go back to our dark color. Halfway in between every vertical asymptote is what? Halfway between your vertical asymptotes? Intercept is 0 again. There, there, and there, and there. Okay? Those are your intercepts. Why in the world does that keep showing up? Okay. Now, what's halfway between your intercept and your asymptote and your intercept? Yeah, well, it's not amplitude anymore, but it's your plus or minus A. Now, what does the minus indicate here? No, it's reflected over the x-axis. Remember, that's what a negation does. You're negating the y, which is flipping it over. So normally, this would be below here on the left. Now it's above here on the left. So at plus 3, and then down here to minus 3. Up here to plus 3, down here to minus 3. That's where your A comes in. Minus or plus, plus or minus your A. And this one would be up here again. Going this way, that's your plus 3, no, yeah, I already drew that one in. Minus 3 here, plus 3 here, minus 3 here, plus 3 here. Okay, so here's what it's doing. Coming down from the vertical asymptote, boy, this is not much deviation at all. Whoa. Because guess what? That was a vertical stretch. Okay. You stretched it up so you have a lot less of a wiggle in there. You stretched it vertically. Okay. So there's how that one. The The minus flips it across the x-axis. And your A, meaning you're going from plus 3 to minus 3 at your quarter periods, which would be at your 8ths of a pi. Okay. Does that make sense? Yay or nay? Make sense? Okay. That was example 2. They have a checkpoint after that one as well. Okay? And you'll see they did the same thing we did with their little table. All right. All right, moving on to cotangent. Y'all okay with tangent? All right. What would the graph of the cotangent look like? What can you tell me about cotangent? It's what? Okay, it's reciprocal of tangent. So therefore, everywhere a tangent was a 0, cotangent is a vertical asymptote. And everywhere tangent was a 0, that's where your zeros are. Tangent was a vertical asymptote, that's where your zeros are. Cotangent. Yeah, because it's reversed. It's cosine over sine. So anywhere sine is 0, which are at your whole piles. 0, pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi. Those are all your vertical asymptotes. And that's where your cotangent is not defined. And because tangent was reflective across the origin, so is cotangent. It just doesn't look the same, but it is. Okay? And because they're reciprocals of each other, the periods are the same. So the period of tangent and cotangent are pi. All the rest of them are 2 pi. That's the basic function with no b in there. B equals 1. You can see the cotangent function as vertical asymptotes when sine is 0, which are at all your whole pi's. Okay? 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative 3 pi, and 0. Okay. The graph. Cotangent function is shown below, and you see again it's reflected about the origin, where cotangent is going to positive infinity here, it's going to negative infinity there. Okay? Where it's going negative infinity here, positive infinity there. So, if you do this, y is equal to a, cotangent b. I don't like writing it this way, but bx minus c. It can be found by solving the equations. And now you do 0 to pi. Those are your vertical asymptotes. Guess what? If you just do it this way, again, don't ignore the a. That's going to be your quarter periods. That's going to be the plus a and minus a. Okay? The b is going to influence your period, because pi over b is going to be your period. The c is going to be your phase shift, one way or the other. And things like we said, the period is pi. This is plain cotangent x. No a of 1, a b of 1, and c is 0. Okay? The period is pi. Domain is all values except your whole pi's. 0, 1 pi, 2 pi, 3 pi, negative, so on. Range is just like tangent, minus infinity to infinity. Vertical asymptotes are at your whole pi's. Okay? And it's metric about the origin, meaning it's an odd function. Okay. So let's sketch the graph of this one. Y is equal to 2 cotangent x over 3. What are your parameters here? Help me. What are your parameters? Anybody? A is equal to 2. B is 1/3. And what does that imply? The period is what? What's your period?
3 pi.
Okay, 3 pi. it's it's pi divided by b. B is 1/3. When you divide by 1/3, you multiply by 3. Okay, so it's 3 pi. Okay, then what's the next thing we do? Divide by 4, and that gives you 3 pi over 4, which is sort of an awkward interval, but we can live with it. Okay, there is no phase shift. The C is 0. So I think we're ready to go. Oh, man. So we're going to do our intervals in 3/4 pi. Okay, sort of sounds like 3/4 time that you're doing in music or something. 1, 2, 3. And you could do it in 1/4 pi if you wanted to, and then do every third one. It's not that bad doing it this way. And here we know we're going to go up at least 2. Okay. All right. Get out of there. Okay. So this is going to be 3/4 pi. If you do it this way, this will be 3/2 pi. And this will be 3 pi. Okay. 1, 2, 3, 4. 1, 2, 3, 4. This will be 6 pi over here. This will be minus 3/4 pi. Minus 3/2 pi. Minus 3 pi. And so on. Okay. Now, what happens when x is equal to 0? What happens when x is equal to 0 for a cotangent? When x equals 0, what? The cotangent is 0? Undefined. That's one of your vertical asymptotes. So let me go back to red here so we can, yeah. So, oh yeah, it's right here. X equals 0 is a vertical asymptote. And then every period after that, so that would be 3 pi, 6 pi, minus 3 pi. Let me get this ugly writing out of here. And I didn't get minus 6 pi on here, but it's somewhere out there. Okay? Now, what's halfway in between every vertical asymptote? Your intercept. I'm going to move this over a little bit. Right there, right there, right there, right there. Okay? Now, here is the part, and it really, if you're used to seeing cotangent, it's not surprising to you. But if you're not used to it, remember this. In the first quadrant, what is the sign of all your trig functions? Positive. So in this first quadrant, this has to be your plus 2. Okay? So you have to be in the first quadrant. See, this is your first quadrant, second quadrant, third quadrant, fourth quadrant. You know, so that's how these things split up. So you've got to be positive here. So that's going to be your plus 2 up here because that's your A. And then your minus 2 is going to be down here at that quarter period. Plus 2 up here, minus 2 down here. Minus 2 down here, plus 2 up here. Minus 2 down here, plus 2 up here. So here's basically what this looks like. I don't draw these very well. Okay, they're ugly, but they're there. Okay, that's what the cotangent function looks like. Remember, everything's positive in the first quadrant, so you better have positive values there. The only way to get that is to be going down here. Okay, so things to note about this: the cotangent function is always decreasing. unless there's a minus sign in front, and then it would be increasing. The tangent function, always increasing, unless there's a minus sign in front, like we did in the last example, and then it would be decreasing. Does that make sense? If you do your parameters just like before, the A, this time it's going to be your quarter periods, plus A minus A. So don't throw out the A. Remember that. The B, that's going to influence the period. Pi over B, in this case, 3 pi. Okay? And then your, once you got the period, take a quarter of that, and that's going to be your interval. And your quarter at the intercepts, they're going to be at 0, and at the halfway between them, actually, again, first best thing to do is do your vertical asymptote. And you know for cotangent, unless there's a phase shift, it's going to be right on your whole periods. That usually starts at 0. 0, 1 period, 2 period, minus 1 period, minus 2 periods, and then you're halfway in between the vertical asymptote is going to be your y-intercept. Halfway in between the intercept and the asymptote is going to be your plus A and your minus A. Whichever order you're supposed to do. It's pretty easy to do, really. Do it your quarter periods, and then identify where your asymptotes, then your intercepts, and then your quarter periods, plus or minus A. Pretty straightforward. Okay, so that was example 3. Now, let's clear the screen so you can see how they did it. Okay, they do this and it's perfectly fine. You'll see you get the same thing we did. You get x equals 0 and x equals 3 pi. Using your b, you get the same thing, okay? In fact, you're using your b. You're multiplying by 1 over b, which is, you're dividing by 1 over b, which is multiplying by, you're dividing pi by b, which is multiplying by 1 over b. Okay, I'll get it right someday. So 0 and 3 pi are your first two vertical asymptotes, which is exactly what we did. You can see that all your vertical asymptotes are the multiples of those. All right. Now, same thing we did. They locate that first vertical asymptote and 1 period over the next vertical asymptote. Halfway in that, your intercept. Halfway in between those, your plus A and minus A. They did it without saying that's what they're doing, but that's what they're doing. Because you plug your quarter period in here, that's always going to be 1. 2 times 1 is 2. Okay. On the lower side is going to be minus 2. All right. Does that make sense? They're pretty straightforward, pretty easy to do. And if you do the same pattern you did with sine and cosine, usually it works. Just remember the differences. Period for tangent and cotangent is 2 pi. All right, and here's how the graph looks, and that was relatively similar to what we did. Your whole periods, minus 3 pi, 0, 3 pi, 6 pi, and so on, minus 6 pi out here. Those would be your vertical asymptotes. Halfway in between that, 3 has pi, minus 3 has pi, positive 3 has pi, whatever the connection is. Whatever. 9 has pi, whatever that is. That's where your intercepts are, and then halfway in between the intercepts and the vertical asymptote are your plus 2 and minus 2, plus 2, plus 2. If you got those down, you've got the shape. It's going to be there for you. Thing to remember, in the first quadrant, unless it's a minus sign in front of it, the first quadrant, everything's positive. Plus 2 there makes the minus 2 over here. And once you got those two, all of them fit. Okay, now we're going to do the reciprocal function. We just did a reciprocal function. Cotangent is reciprocal of tangent. But we're talking about the other two, the reciprocals of sines and cosines. Now, and this is exactly how we graph it. You can obtain the graphs of the two remaining trigonometric functions, secant and cosecant, from the graphs of sine and cosine because they're reciprocal to those. Cosecant is 1 over sine, and secant is 1 over cosine. So what should be one of the first things to come to mind about cosecant? Warning, 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 don't go there, say again. Okay, reciprocal of sine, so anywhere sine is 0, cosecant is undefined. And where cosine is 0, secant is undefined. We already know where sine is 0. Where is that? Anyway, where's your sine 0? I like eating them. Whole pies, yes, okay. The whole pies. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, -1, you know. Just like the cotangent. The cotangent, cosecant, they have the same vertical asymptote. And where cosine is 0, those are your half pies. And that's the same as for tangent. So tangent and secant go hand in hand, sort of. They have the same vertical asymptotes. The same thing you did for tangent vertical asymptote, you do for secant. Same thing you did for cotangent vertical asymptote, you do for sine. Get those drawn first. You're already almost halfway through your problem. Okay? Now, actually, it's easier than that. It really is easier than that. You don't have to, you do have to remember something, but you don't have to fiddle with it. I'll show you in a minute. For instance, at a given value of x, the y-coordinate of secant x is reciprocal of the y-coordinate of cosine x. Okay? Of course, when cosine is 0, reciprocal doesn't exist. Near such values of x, the behavior of the secant function is similar to that of the tangent function. It's going to either positive or negative infinity. But it's really even easier than that. Okay? So in other words, the graphs of tangent, which is sine over cosine, and secant, which is 1 over cosine, they have the same vertical asymptotes, okay, where cosine is 0. That's your half pies, okay? But it's even easier than that. You don't even have to worry about it as soon as I show you how to do this. The cotangent is same. It's cosine over sine. Cosecant is 1 over sine. So they have the same vertical asymptote. That's your whole pies. But it's even easier than that, okay? I keep saying it. It will be. Here's the key. To sketch the graph of a secant or cosecant function, first make a sketch of the sine or cosine, the reciprocal function. Do that first. You know how to do that. They're easy to do. Okay, so if you're doing cosecant, first sketch the sine. And they're easy to do. Just put them in there. Then do the reciprocals, and that's where it becomes amazingly easy. Okay? So here's what you do. Cosecant function. First do the sine function. And write down everything you need to know about sine. A is 1, B is 1, C is 0. So it's going to be going through 0, 0, your quarter pi, 2 pi over B, which would be 2 pi, is going to be 1 period. Your quarter periods are going to be pi half, pi, 3 half, pi, yeah. You got everything. Just draw your functions in. Okay. Sine function is easy to draw, right? To draw. Now, once you get that drawn, you don't have to worry about anything else. Here's what you do. Everywhere the sine crosses the x-axis that's dividing by sine, those are your vertical asymptotes. Everywhere the sine crosses the x-axis, there's a vertical asymptote. Just draw them in. Okay? You don't have to worry about whether it's whole pies or half pies. If you drew the sine right, everywhere it crosses the x-axis, there's a vertical asymptote. Then, what you do from there, where you have a valley down here, go in the opposite direction. Where you have a hill up here, go in the opposite direction. Approach the vertical asymptote, kiss there, they touch there at that place, +1, -1, +1, -1. It's the only place they have in common. Those are reciprocal. 1 over 1 is 1, 1 over -1 is -1. So they're there, and then they go in the opposite direction. So this is going up like this is going down. So this is coming down, that's going up. And they approach the vertical asymptote. So that's all you do. plot your sine and cosine, okay, and then draw your vertical asymptote everywhere the parent function crosses the x-axis, okay, and then kiss and go, okay. That's all you do. Kiss and go to the opposite direction at the peaks in the valley. They're so easy to plot. Now, you look at them and say, yeah, the period's back at 2 pi because their reciprocal function was a period of 2 pi. Domains, all x's except where your parent function was 0, which for the cosecant, that would be sine, that would be at your whole pi's. For your secant, that would be cosine, that would be at your half pi's. Vertical asymptotes, that's exactly where they are. Now, here's the difference these have with all the others. Sine, the range is between plus or minus 1. Sine and cosine. Tangent, all real numbers. The range is all real numbers. Secant and cosecant, because they're reciprocals of sine and cosine, or sine, cosine and sine, they're everything above plus 1 and below minus 1. They never have values between plus and minus 1, ever. That's where sine and cosine live. So the secants and cosecants are outside of that. Always from negative infinity to negative 1, from positive 1 to positive infinity. That is always the range for your secant and cosecant. And because the sine function is odd, so is the cosecant function. Because the cosine function is even, so is the secant function. So those are the only 2 even functions of your 6 trig functions. All the other 4 are odd functions. So secant and cosine are the only 2 that are symmetric about the y-axis. All the rest are symmetric about the origin. Does that make sense? You would think they'd be the hardest to draw. They really turn out being the easiest. Okay? Now, I think we've just said all this, but say it again. In comparing the graphs of secant, cosecant, secant functions, those of sine and cosine, respectively, notice the hills and the valleys are interchanged. So if you have a hill on the sine, maximum on sine, that's going to be a minimum on the cosecant. Minimum on sine is going to be a maximum on the cosecant. Okay? Just remember, they go in opposite directions. Okay? For instance, a hill or maximum point on the sine curve, yeah, we said that, we said it. Okay. Any questions about that? So, first thing, draw your sine. Then, every place that the sine is 0, your cosecant is going to have a vertical asymptote. Everywhere the sine is a max, it's going to be a min for the cosecant. Everywhere the sine is a min, a max for the cosecant. So it goes in the opposite direction. You don't have to plot any more points. You plotted them all with the sines, got your vertical asymptotes in there, and take this and go up, take these and go down. Approach the vertical asymptotes, but don't ever touch them. They're done. Just like that. Remember, they're never pointed. They're always curved. Additionally, the x-intercepts of the sine and cosine functions become vertical asymptotes of the cosecant and secant functions, respectively. We've said it a dozen times. Okay. So let's do example 4. Where would you begin? Where would you begin? Sketch the graph of y is equal to 2 cosecant x plus pi fourths. Where would you begin? Say again? What value? Oh, okay. Before that, first go to, yes, let's do the sine. So let's do, now you want sine in a different color or you want sine in black, and we'll do the cosecant in a different color. I don't care. Which you want? Okay, you pick a color. Red. Okay, I sort of like red, using red for my vertical asymptotes. Can we do a different one? Blue. Light or dark?
Light.
Second? Light? Okay. All right. Oh. Okay. Let's go back to dark here so I can draw my axes first. No, that's actually not what I wanted. I wanted to do my sine first. You said light or dark?
Light.
Light. Okay. So let's do first y is equal to 2 sine x plus pi fourths. Okay? Now we do your A, B, and C. So what's your A? 2. B? What does that imply? Okay, and so the period is what? 2 pi over B, which is just 2 pi. And then we do from that, period over 4 would be pi halves. That gives you your interval. Okay? And then what in the world is this pi fourths out there? Phase shift. Okay, what would be your phase shift? Not quite. Minus pi fourths. Remember, it's always the opposite because it's something happening to the x value. Always the opposite sign. Okay. So now let's go back to our dark color and we'll draw our graph. Okay. All right. Our phase, our interval is going to be pi fourths. So we'll do 1. Okay. And we'll go up here at least 1, 2, 3, 4, 5, 6, 7. Okay. Now, those aren't very evenly spaced, but we can live with them. Where do we begin? At the phase shift. Okay, so let me go back to my light blue. Let me go back to my dark. And we'll do pi fourths, pi halves, pi minus pi fourths, minus pi halves, minus pi. On and on. This will be 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. Now, we begin at the phase shift. So we'll go to negative pi fourths. And where does sign usually begin? At 0. And then you go up to 2, down to 0, down to minus 2. You go up your amplitude and down your amplitude. Okay, 0, plus 2, 0, minus 2, 0. In the opposite direction, minus 2, 0, plus 2, 0, minus 2, 0. So that's what our sine function is going to look like. Ooh, I don't draw very smooth curves. They're usually pretty wavy, some worse than others. All right, now, where do we go from there? Draw the asymptotes. Where do you draw them? Absolutely. So there's an asymptote there, and asymptote there. An asymptote there, and asymptote there. See, that phase shift has sort of messed up everything. That's why you start there, because it drags the whole thing. So draw your asymptotes everywhere the sine function crosses the x-axis. All right? And then what do we do from there? I think we're ready to draw our... What's that? Oh, super. Excellent. Is it time? Oh my goodness, how could that happen so quickly? You'll need to warn me a little bit. Okay. If you look in the book, you'll see, okay, real easy to do from this point on. Just draw from every valley go down, from every hill go up. From every valley go down, from every hill go up. Approach the vertical asymptotes, but don't touch them. Okay? That's what you do. All right, homework exercises here. I would do all of 9 through 14, or all that you can do. I think you can do them all now. The odds will be in the back of the book and also at Calc Chat. And I think you can do any of the odds 15 to 37. Okay? They're all at Calc Chat, 19's at Calc View. And I think you can do all the odds 39 to 47. They're all at Calc Chat. We'll do the rest of those later. I think we finished example 4. What I'll do for anyone viewing at home is erase this ink and then show how they did it. Very similar to what we did. Period is 2 pi. Then they did their asymptotes this way. I did it another way. They're perfectly fine either way. But that's what it looks like. Same as what we drew. Okay. All right. We'll start next time with example 5. So I'll end the